Okay, today is day 2 of our new unit. What is it about? What did we learn yesterday? What kind of functions? Rational functions. Good. And the rational function is basically this, except a little more complicated. All right, with this one, if I did this to it, and then did this to it, I just changed where its asymptotes are because I moved it. I see a cell phone out, put it away now. Any other phones out, put them away now. Not in the crack in your iPhone, not sitting on your desk. Away, gone. Right. So I'd like you to tell me what this kind of looks like. Just a quick sketch, and that means find where the asymptotes are. Right? Then, that was kind of an easy one for our step B. And again, I want to give just a few minutes to like answer this. What if we had this? I'd like you not to sketch this one. That's what I'm going to teach you today. But on this one, I'd like you to tell me what the horizontal asymptotes are and the vertical asymptotes are. All right, that's a good review to start with. I'll pause while you give that a shot for a few minutes. And okay, how many guys are done? That's a little less than half the class. I'm going to give you a little bit more time. Okay, I think I need to start giving you the answers here. So first off, this graph would have been like this to start with. This is just a rough sketch. I'm going to put in the asymptotes using my fancy dotted line drawers. There we go. Okay, so basically there's your 1 over x function, but this guy's been moved. It's been moved. What's this mean right here? Left 3. What's that mean? Up 7. Okay, so if I go left 3, that's going to move this asymptote over 3. Notice if I move this asymptote, it doesn't even matter on the left part. Okay, oh, wait a minute, I just moved it right. Sorry. Left 3. There we go. Okay. Now, I also need to move up 7. Okay, when I move up, that'll move this asymptote. Not that way, the whole thing. Come on. There we go. Up 7. And then my graph needs to kind of follow along. And there we go. This was just an arrow saying where it was. So there's generally where it should be. Raise your hand if you put it generally there. Okay, good. Now, that's a rational function, but it's a pretty simple one. Do you remember the whole horizontal thing about bigger on bottom, bigger on top, same on both? For the horizontal asymptote, which one is that? The pink one or the green one? Which one's the horizontal asymptote? Say it if you know it. Which one's the horizontal? The pink one or the green one? The pink one. Okay, good. So if the pink one is the horizontal, then which one of those two things affected the horizontal? Did this affect the horizontal, the 3, or was it the 7 that affected the horizontal? The 7. So the horizontal was affected by what was outside of the fraction. Okay, so those rules again, bigger on bottom, bigger on top, or same on both. For this new one here, is this bigger on bottom, bigger on top, or same on both? Same on both, because if I multiplied it out, the lead coefficient, or the lead term here, would be negative. No, it wouldn't be negative. That'd be important if it was, but this one I'd take x and its power of 1, and this x and its power of 1, and it'd be x squared to be the lead term. Lead term down here, x squared. So they're both degree 2, which is why they're the same on both. All right, and have you got these rules memorized already? Bigger on top, bigger on bottom, or same on both. Remember that these are all for horizontal asymptotes, and the rules there are all for y equals things. Remember me saying that dumb word to remember that horizontals were the y things? What was that dumb word? Horizontals. Because if you see y equals this and x equals that, you should be able to just go, oh, that's a horizontal and that's a vertical. Because it's confusing. It's confusing even for me to remember which ones are which. So I made up the dumb words, and now I got it forever. Vertical and horizontal. All right. So the y equals things, what were the rules again? I'm going to call on random person, Dice of Destiny. Who should I talk to? It's row 6, person 3. Row 6, person 3. That's you. What do you think the rules are for bigger on top? Do you remember it? None. No bots. Okay, there's no asymptotes for horizontals if it's a bot. Bigger on top, okay? How about bigger on bottom? Row 2, person 4. That's you. Sobs. You forgot, didn't you? It's okay. So I'll remind you, Bob is an outsider. It's whatever's outside. Let me look back at these. Remember how this was outside? And it's a Bob because it was bigger on the bottom, and so it's an outsider. The 7 is what mattered. Y equals 7 for that one. This one, what's outside my fraction? Nothing. So it's y equals nothing. How do you write y equals nothing? Y equals 0. All right, so again, it's y equals 0 or whatever's outside. And if there's nothing outside, then there's a 0 outside. So again, if you had this, do you get that that just moved that whole thing up 8? So that brings that Bob asymptote, which would have been 0, and moves it up 8. So Bob's an outsider. That's the way to remember it. It's y equals whatever's on the outside. All right, and last thing, same on both. What's the rule for Sobs? They make you sob because it's harder than all the other ones. Yes? The ratio of the leads. Good. And in the case of this problem, what were the lead coefficients? Well, it's this and this are the lead terms. What's the number in front? 1 and 1. So it's y equals 1 over 1. That's the rules. It's the ratio of the top and the bottom, and I shouldn't say it's always 1 over 1. It's y equals the ratio of the lead coefficients. In our case, in this problem, it was a Sob, same on both, because these were the same, and it led to y equals 1 over 1, or y equals 1. All right, now I'd like you to find in the new homework that's posted for today, it looks like this, except I have it on the other screen, so I'll drag it over here. I believe this is like the 9th slide in the file for today's. It says, let's see what it says on the top. It says 7.2 day 1. And again, this is posted on today's date, which is 11-21. Find this. It's about the 9th slide. Okay, would you turn your iPads my way so I can see how many of you have found this exact slide? All right, I'm dealing with 90% of my kids have got it, so awesome. I'll come and check on those last 10 in a minute. All right, so here is practice. Well, first off, this looks totally different than what we've done before. Why? It's not factored. What's my favorite saying? If you can factor it, you should. So factor it. I can still tell that this is the same on both because I can, in my head, just multiply this out and say, oh, it's going to have an x squared in it. But still, it'll be of value to factor it. Because why? Because it'll tell me if either of these are going to cancel with something on top and create a whole. All right, so try that top one. And find its, well, first of all, remember domain is everything works except what? So a domain is what can you safely feed this function? And you can feed it anything except something will crash it in the denominator here. So whether it makes a whole or an asymptote, either way, it's going to crash your function. So the domain is everything except things that crash your function. The verticals come from here. The horizontals come from those rules, Bob, Sob, and Bot. And lastly, holes are where there's something that cancels on the top and the bottom. Something that would have crashed your function, except it cancels on the top. All right, once you get that factored, try to answer those 4. I would like you to compare with the person sitting next to you. In this case, it's rows 1 and 2, rows 3 and 4, rows 5 and 6. Compare with the person across from you. In my 6th-hour class, I usually pair you with a certain person because we have kind of weird rows. So check with the kid near you after you've done this for about 3 minutes. Check just problem 1. I'm going to pause while you work on that. Okay, I'm seeing kids are like comparing with the kid in front of them or behind them, but then that leaves out the kid that you're actually supposed to be paired with. So would you please officially slide next to the person that you are going to work with during the next few minutes? 6 inches apart. Yes, for you it's behind you because, all right. And you're going to work with people behind you because you're a group of 3, all right? Okay, and actually it would be easier if you two paired up. Would you go over there? Thank you. All right. Would you slide into a group of 3 right there with Miss T? All right, so this top gets factored. Oh, wait, you're just talking to the other person. I apologize. I'm going to pause while you talk to that person about those 4 answers for number 1. Okay, let's see how you did. First of all, if you can factor it, you should. And so, did you factor it? Let's see who I'm calling on here. It's row 2, person 4. And, yeah, it really likes you today. All right, x minus 9, x plus 1. How many of you think he's right? All right. And how could I know he's right? 9 and 1, sorry. Here we go. Now do I have it right? Okay, good. How do I know he's right? I'm going to just quick outside and inside it and find out that the middle term is this, and yay. That's the ones that usually mess you up, is the middle term. All right, so I got an x minus 9 and an x plus 1. What do I care? Why do I care? Because the x plus 1 here will cancel with that x plus 1 and create a whole. And the whole is at x equals not 1. Is 1 the thing that would crash the function? No. X equals negative 1. That makes a whole. Now, when we get more advanced, we are going to say exactly where the whole is. It's when x is negative 1, but then you actually plug that into the resulting function. That's gone because we've factored it up here. That's gone because I canceled it with that. The resulting function is this here, x minus 9 over 3 times x minus 3. Now I want to teach you this today, how to find the rest of the whole. The whole's at 1 comma something. You get what I'm saying? A whole is a point. It's a point that's missing from the graph. And this is where it should be. It should be at negative 1 comma. What do you think I'm going to do with that negative 1? Plug it in. Not into here, it would just crash it. I got to plug it into the resulting function right here. And I'm sticking in a negative 1. Do you get that makes negative 4 times 2 or times 3? Negative 4 times 3 makes negative 12 on the bottom. And on the top I have negative 10. And then I can simplify that down to positive 5, 6. So that's my point, 1 comma 5, 6. Can anybody verify that? You got the same thing as me? Okay. All right, good. Okay. That's exactly where the whole is. And I would have understood if you just said there was a whole at x equals negative 1. But now you need to get better, more exact. The whole was at negative 1 comma what? That will be required. Okay, next part is horizontal asymptotes. I'm going to erase a little bit here. The horizontal asymptotes are the whole bigger on bottom, bigger on top, same on both deal. Is this one a bob, a sob, or a bot? It's a sob. It's the same on both. So then it's a ratio of the lead coefficients. What's the lead term on the top? X squared, 1x squared. And what's the lead term on the bottom? 3x squared. And then I can say it's a ratio of the coefficients, which is the 1 and the 3. And that makes it 1/3. So, by the way, if you had your horizontals and verticals mixed up, you could remember it this way. The verticals are the zerticals, and the horizontals are the horizontals, right? And so I just figured out the horizontal rule. So that's y equals 1/3. Those verticals, they come from the denominator. One of the most common mistakes is to think both of those are a vertical asymptote. X equals negative 1 and x equals 3. And I get why people think that, because they are things that crash my function. But one of them was a whole. Remember which one was the whole? The -1 was the whole, right? Okay, so that means this can't make an asymptote. It makes a whole. It's one or the other. Okay, and so we already figured out that one was a whole. So then really the only vertical asymptote was the x equals 3. Correct? Okay. All right, then the last thing is the domain. The domain is everything works except what? Well, we go back to what crashes this function. We don't care how it crashes it, but those two things crash it. -1 and +3. So all reals except x cannot be -1 and x cannot be +3. There's other ways to write that. You can write it with parentheses and infinities and stuff. If you wanted to do it that way, it'd be -infinity until it hits -1, it works, then union, then it works between -1 and 3, and then you'd say from 3 to infinity. That's how you do it in interval notation. Okay. Raise your hand if you're feeling good about at least 80% of what I've been telling you. Okay, good. So that's all review, except the new thing was how to find exactly where the whole was. And you take the x value of it and you stick it back in the function. Not the original function, it'll just crash. In the function after you canceled the whole. All right, now let's get to the new stuff. Here are the steps for constructing a sign diagram for a rational function. Find this file. For those of you who are the type who actually like to read it instead of having somebody read it to you, I'm going to pause for a moment and just ask you to read these. These are steps you should make to figure out a sign diagram. Okay, so I think this would work better if we had an actual problem. And I think this number line's pretty confusing, so we're not going to use it. That was somebody else's ideas. I'm sure they have a wonderful thought of what to do with it, but I want to just use normal numbers. Let's say I had x plus 1 over x plus 3, and that was my simple little rational function. You want to know what it looks like? Well, first of all, we're going to have to be able to do this called testing intervals. Okay, so I need to first do this step 1. Values excluded from the domain. What the heck is that? Well, in this case, what's the thing that doesn't work? -3. So make a number line and put -3 on it. Now, would -3 be an acceptable thing to put in the function? No, so I leave it empty. Do you get that everything else would be acceptable to put in the function? Okay, but would it make it, this is a sign diagram, so the question is kind of would it work or not? All right, so find the zeros of it. Okay, those are the things that make this function 0, and put them on the number line with a 0 above it. Okay, what's the 0 of this function? It's the thing that makes this function equal 0. Do you get that the thing on the top? A lot of people think if I put in -1, this function will crash. No, it won't. If you put in -1, what will happen? It'll make it 0. So -1's also important. I want to put -1 on this. I have to be careful where I put it. There's -1. That's an important spot. Now, this is important. Will that spot crash my function? No. It's just a 0 of the function. So I put a z above it for 0. And this little thing, it says I'm supposed to put a question mark above it. I'm going to call this, I can't remember, what do we usually use for that? That's something that's not going to ever work. It's either a 0 or it's a, I guess I'll put a question mark above it. That's what it says to put above it. I think I had a different letter for it last year, but it's okay if we put question marks. Okay. Next, I'm supposed to test a value in each of the intervals. What that means is I'm supposed to stick a number from here, 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 those 3 spots, those 3 zones. I'm supposed to test a number and determine the sign of this function for each value. All right, so if I stick in negative, let's see, what's above -1? How about 0 would be up here, wouldn't it? Let's test 0 and see what we get. It's really quick and easy. I get 1/3. It came out positive. Why do you care if it comes out positive? Because eventually, down the road, we're going to be saying, when is this less than or equal to 0? That's the kind of question we'll be answering. And we need to know when it's positive, when it's negative, and when it's equal to 0. All right. So I'd like you to test an interval, a number here and a number here, and see if you think this comes out positive, negative, or 0 when you test one of those numbers. So for instance, in here, you're going to test maybe -2, and you're going to see what happens when I stick that in the function. This first one, it came out positive in here. And then let's say this one comes out negative, you would write neg. I'm not saying it's negative, but I'll let you try testing 2, and then test something in this last interval with your partner. I'll pause for a minute while you try that. From my experience, testing intervals is one of the things that people are the worst at. So you got to practice this. Okay, that doesn't take too long, so hopefully you're done. You stick a 2 in. You stick a 2 in this function, and what happens? I get 2 plus 1 is 3 over 3 plus 2 is 5, 3/5. All that matters is, was it positive or negative? It was positive. Raise your hand if you knew that interval was positive. All right. Right? Oh, it's supposed to be testing a negative number. It's a -2. See my line there covered up the negative? Sorry, that's a -2. Thank you for catching me. I should put in a -2 and a -2, and I know some of you fell into the trap with me. I apologize. I wasn't trying to trick you. All right, so I'm putting in a -2. -2 plus 1 makes -1 over -2 plus 3 makes +1. Ooh, that does come out negative. I was telling you the kids are terrible at this. Well, apparently, sometimes the adults are too. Move this over here because I can't seem to delete it. I'm going to hit negative in this zone. Okay, and now testing -4. Let's see what happens. -4, -4. This part comes out negative. This part comes out negative. And now, this is one of the tricks to it. You don't actually even have to know what number it was. It was just a negative divided by a negative. Didn't even matter what the numbers were. It's going to come out positive, right? All right. So the function would be positive in this zone. Do you get when they tell you, okay, so here's my function. When is it greater than or equal to 0? Do you get from this sign chart, I can say, oh yeah, it's in this zone and this zone where it's greater than or equal to 0. Okay, that's what's coming down the road, and I just want to practice testing intervals with you. So now, let's see if you can, I'll pause for a second while I deal with the tech issues. Excellent, okay. All right, tech issue fixed. Get to this slide, please, that says steps for graphing rational functions. That whole sign chart thing will come in handy eventually. All right, so a typical question might be like, graph this. X plus 3, x minus 4 over x plus 3, x minus 7. Right away, you'll look for stuff to cancel because it'll make your life a lot easier. Do you see something that would cancel there? Okay, so let's say my job was to graph what's remaining. First of all, can you just cancel this and forget about it? No. You cancel that, and remember that that creates a what? A hole. There's going to be a hole in the graph. It's one of the most easy things to forget on the test is you canceled something and you forget to go back and put a hole in the graph at that right spot. All right, so it says find the domain of R. Do you get the domain is everything that will work, and everything works except what in this case? Everything works except 7. Okay, so the domain of ours is all real numbers except 7. Now it says reduce it to its lowest terms. That's kind of what we just did with canceling. Okay. Third step, find the x and the y intercepts of the graph if they exist. All right. The x-intercepts are where, finish that sentence. Y equals 0. Very good. I'm glad to hear a lot of people remembering that. X-intercepts are where y is 0. Think about that. That means, how do I make my little example problem there equal 0? Remember, things that make the bottom 0 are a problem. Things that make the top 0, just make it equal 0. So what makes the top 0? A 4. Do you get 4 is a special number for this function because it makes the function equal 0. A 0 on the top is not a problem. All right, so that was the x-intercept because I set y equal to 0. My x int was 4. And if it's an x-intercept, y equals 0, so 4 comma 0 would be another way to say it. Do you get if I'm going to graph this thing, I would now know that 4, 0 is a dot on this function. Okay. Next, I got to find the y-intercepts. The y-intercepts are where x equals 0. So I'm going to clear out this one where I set the y equal to 0, and instead I'm going to figure out setting x equal to 0. If I put a 0 here and a 0 here, that's negative 4 over negative 7, which is 4/7. So the y-intercept, 4/7. The y-intercepts are where x is 0, right? So 0 comma 4/7. There's a dot right here. There, I found the x and y intercepts. That's step 3. Step 4. Determine the location of any vertical asymptotes or holes. Oh yeah, that's stuff we were just doing earlier today. The verticals are the things from the bottom, like x equals 7. So x equals 7 is a spot right out here on my graph. That's the vertical asymptote. How about the horizontal? Bob is the one we should ask on that. That's the way I like to say it. Bigger on bottom, you know. Is this one bigger on bottom? No. Bigger on top? No. Same on both? Yes. If it's a sob, same on both. We take a ratio of the lead coefficients. Remember, I was just temporarily sticking in those zeros. The lead coefficients on this puppy would be 1x over 1x. So my ratio of the lead coefficients is y equals 1. So here's a spot at y equals 1. Now, can you start seeing where the graph's going to shape up? It's going to be kind of like this. But we need to like finish it to really know exactly where that graph's going to be. I know those 2 spots on the graph, the 2 dots, but I got to like, where's the rest of it? All right. To determine the location of vertical asymptotes or holes in the graph, well, there was a hole. See, they put that in as step 4 because they don't want you to forget that hole. The hole was at -3, and -3, when it's stuck back in, gives me -7 over -10, -7/10 when I stick in a -3. So my hole, and I'll put it over here, hole is at -3 comma, did I say 7/10? Excellent. So I'd like you to put, this is weird, you don't put a dot there. You go to -3 comma 7/10 and put an empty spot there. But the graph goes through that empty spot. It just doesn't go inside the empty circle. Do you get that was part of this thing? If I was going to make my finished graph, it looks kind of like that. Okay, and now it's asking me to analyze the end behavior and find any slant asymptotes if one exists. We're not ready for slant asymptotes. I'll teach you that on a different day. And now, here's the important part. Use a sign diagram and plot additional points as needed. Okay, that whole sign diagram that we practiced earlier is going to come into play now. Now, it's got another set of rules for plotting these points, but do you get the essential here is that we've plotted some points. We need some more points. I got to figure out a few more points so I can start connecting the dots. How do I get more points? I stick numbers into my function, or I use that sign chart. All right, if I'm going to use the sign chart, what were the important things? The important things were where it made it 0. What made this function 0 was 4. And what crashed it? 7 crashed this function. And then I'm supposed to test around it and figure out if it's positive or negative or 0. All right, my opinion is that the sign chart for these isn't as handy. Right now, I should just find a few more points. Because even if I find out that it's positive, let's say I put in a number out here and figure out, oh, it's positive. Still doesn't tell you where the dots should be. So I need to actually just find a few more points. Got my asymptotes. I got a few important points. I need more. All right, so then what's bigger than 7 out here? Let's just put in an 8. Do you remember me saying that the thing that helped you more than anything else on graphing was your XY chart? Yeah, XY chart solves a lot of problems. So off to the side here, please make an XY chart. And if all you did at the beginning of this function was graph a million points and then connected the dots, it would have worked. You get what I'm saying? Pretty handy to know where the asymptotes are, but if you just stick in numbers, see what you get. So let's stick in something bigger than 7 because I want to kind of find out what some points are over here. So let's put in 8 and see what I get. If I put in an 8, I get 8 minus 4 is 4. Over 8 minus 7 is 1. That's 4. Ooh, 8 comma 4. I can graph that. It's right there. Let's put in another point. 9. 9 minus 4 is 5. 9 minus 7 is 2. 5 halves. What's that? 5 halves. 2.5. 9 comma 2.5. All right, that went down a little bit. Oh, so this thing is dropping here. All right, I wish I could just pull this over and expand it, but here's the final answer. The graph looks like that. Shouldn't touch the asymptote. Should get close, but not touch it. Goes through these spots. And again, this area I want to clean up a little bit. And it'll get closer and closer to the asymptotes. And there you go. That is the 6-step process. I personally would say not the sign diagram as much as an XY chart. The sign diagrams will be handy. I'm glad I showed them to you, but that's going to be more when we have functions that are greater than or equal to 0 instead of just graph this function. XY charts solve everything. Except, I guess, unless you happen to notice where you get a hole, the sign chart might not remind you that there's asymptotes there or holes there. You could do this whole lesson today with just a sign chart, just a XY chart. If you didn't also get the asymptotes and holes, yeah, you'd lose some points, but sign chart, this is more important than almost anything. All right, so let's get to the actual homework and do a couple together. Let me show you what I'm assigning. This is the first page of your homework, which you are going to Dropbox by 8 a.m. tomorrow morning. I will keep the assignment reasonably sized. You get it done. All right, here's the first page. It's got problems 1 and 4 on it. We're going to do both of those. The next page, remember, if you can factor it, you should. So these will have ones that you need to factor. All right, and we're going to do this page also. Those 3 pages. So it ends with, in fact, this says Challenger. I'll leave that just like it says. If you want to prove you really got this down, this will stretch you. You don't have to do this one. Okay, so first 3 pages, except that last problem is not required. All right, now let's start it together. Number 1. Well, there's a 6-step process, but would you agree that one of the steps at least is to find the x and the y intercepts? Another step is to find your asymptotes. All right, so normal asymptotes for this thing would be at 0 and 0, but this guy's been changed. So let's talk about the asymptotes first. Vertical asymptote, horizontal asymptote. I'll ask Bob about the horizontal asymptotes. Is this a bigger on bottom? It is bigger on the bottom. So it's y equals 0 plus whatever's on the outside. Nothing on the outside. Y equals 0. Vertical asymptotes. They're the things that make it crash. They're the stuff down here. And there is one at -2. I'm going to graph those now. Here's x equals -2. Here's y equals 0. Generally speaking, I would expect the graph to be something like this, but I shouldn't just slop it in there. I should actually get a few points. The y-intercept, it's where, finish that sentence. The y-intercept is where x equals 0. Okay, so I'm going to put in a 0, and that comes out to 4 over 2, which is 2. And if it's a y-intercept, x is 0, so comma 2. 0, comma 2. There it is. And then the x-intercept. The x-intercept is where y equals 0. This is a weird one. How can I make that function 0? I can't. What does that mean? It has no x-intercept. Look at the graph. Do you get why it wouldn't have an x-intercept? It's got an asymptote right there. It can't have an x-intercept, so it makes sense. Okay, next. XY chart finishes it off. I told you since the beginning of the year, most powerful tool in graphing, because it can graph anything. All right, so I'm going to stick in a few numbers here. I'm going to put in, let's say, 3, and see what I get. 4 over 3 plus 2 is 5, 4/5. 3 comma 4/5. I don't exactly know where that is. 3 comma 4/5 is kind of like about there. I'm not going to be too strict with you on exactly where 4/5 is. A little less than 1. Let's say I put in a 4. 4 over 6 is 2/3. 4 comma 2/3. It's a little lower than last time. Oh yeah, this is just going to get closer and closer to 0. No sense in even making more points there. And then I kind of know how this looks. It should go up towards, okay, that's all good. Maybe I should make a point over in this little zone. Tell me, what kind of an x would I need to be in that zone? Like an example, negative what? Negative 3 would be good to check. Okay, I'm going to stick in negative 3 on my xy chart and see what I get when I stick in a negative 3. Right here. I get 4 over negative 3 plus 2 is negative 1. 4 over negative 1 is negative 4. So negative 3 went with negative 1, 2, 3, 4. Okay. And now generally, do you get this is going to get closer and closer to the asymptote, and then it's going to make a turn here somewhere? It'd be kind of nice to get one more point in there. So how about we put in like negative 4? If I put in negative 4, I get 4 over negative 2, which would be negative 2. Negative 4 goes with negative 2. Look at that. I almost hit it. Good enough. Do you need to have infinite points? Of course not. Once you get the idea where this thing makes its turn, it has to get closer and closer to the asymptotes. All right, one more thing that I want you to understand. It might freak some of you out. Sometimes your graphs end up with 2 asymptotes, like one here, and there might be an asymptote here. And then when you actually start graphing the points, they start doing this. And then when you start connecting your dots, you'll be like, whoa, that's the answer? Yes. A lot of times the answers will look like that. But notice how, generally speaking, as they get closer and closer to the asymptote, it just kind of like goes towards infinity in that direction. Gets closer and closer to the asymptotes. But what do I need to know where this goes? Again, you can't just like look at the function and go, oh, I know it's going to go this way and that way. You got to graph some points. If you know the x-intercept is like right here, awesome. Then maybe it's doing this. Sometimes it does that. How do I know? You graph a few points. Once you get a few points like this, you can go, oh, so it must be doing this. You need to get some points. How do you get points? XY chart. Okay? So don't be surprised if there's 2 vertical asymptotes and you got to figure out what happens like here, here, and here. That kind of thing happens a lot this chapter. All right. It's a lot of information. You're doing the first 4 pages of the assignment, skipping the one that says challenge on it. Okay, question? I think it was the first, wasn't it the first 4? Was it only the first 3? I'll double check that. Page 1, page 2. You are correct. It's only the first 3 pages. I'm glad you clarified that. First 3 pages, and you can skip the last one there. Okay? Asymptotes, are they important? Of course. You need to find vertical and horizontals. X-intercepts and Y-intercepts. Yeah, they're a big deal. Put those on there. Holes. Most commonly forgotten thing is the little lonely hole on the graph. And last but not least, XY chart, get a whole bunch more dots and connect the dots. All right. There's your assignment. And I will be willing to review this again tomorrow. I don't expect you to be an expert on this. This pretty much is the test. Like, we just went over like almost everything you need to know for the test. You're just going to have a few more days to practice this now. And there is a new concept coming, but this is most of what you're being tested on after, not tomorrow, no test tomorrow, after Thanksgiving time. A couple days into that following week. Okay, that's all I got for you for today.